summing amplifier. Here's the circuit diagram for the summing amplifier. Here's the formula that we get from the formula sheet. Notice we've got two inputs, V1 and V2, and two input resistors. If we had a third input voltage, V3, we'd have R3 also connecting into the inverting input of the op-amp. We're going to go straight into numerical example. So we've got 3 volts going through the 40k, 2 volts going through the 10k, both of them going through the 20k feedback resistor. So let's get the formula and just plug the numbers in. So we've got 3 volts going into 40k, 2 volts into the 20k. We're going to multiply both sides by the 20k, and then we're just going to do the sums. And we end up with minus V out is equal to 5.5 volts. If we just tidy that up with a minus sign, V out is minus 5.5 volts. So this is purely putting the numbers into the formula and calculating. We've got 2 ways to explain how this works. Firstly, treating this as an inverting amplifier, or rather 2 inverting amplifiers. So we've got V1, so we've got 3 volts going through a 40k resistor, we've got a feedback resistor of 20k. So that's going to provide a voltage at V out. Similarly, we've got 2 volts going through the 10k resistor, 20k feedback resistor, that's going to produce a voltage at V out, and then we add the 2 voltages together. So due to V1, using the inverting amplifier formula, so we've got V out is going to be minus RF over Rin multiplied by V in. Plug the numbers in, that's the feedback resistor, the input resistor, and the input voltage. Which means that 3 volts at V in, at V1, provides minus 1.5 volts at V out. Let's do the same for V2. So again, we plug the numbers in, this time same feedback resistor, different input resistor, different input voltage. This is going to give us minus 4 volts, which means 2 volts at V2 is going to be amplified, it's going to provide minus 4 volts at V out. Then what we do, in total, we just add together the 2 voltages, so we've got minus 1.5 volts, add that to minus 4 volts, and that gives us minus 5.5 volts, as we had before. Next way to explain how this works is to calculate the current flowing through the circuit. So first of all, we need to know a rule. Now with negative feedback, this is an amplifier circuit, so the negative feedback makes the 2 op-amps inputs the same. We've got 0 volts at the non-inverting input, so therefore we're going to get 0 volts at the inverting input. Exactly the same as we have with the inverting amplifier. This is the virtual earth. So now we know how many volts we've got here, and at each of these points we can work out the current. So the current due to V1, we've got 3 volts going through the 40k, or going across the 40k resistor, I equals V over R. 3 volts on the input, 0 volts at the virtual earth, 40 kilo ohms, and we end up with this current. We do the same with V2, I equals V over R. This time we've got 2 volts at the input, but again we've got 0 volts at the virtual earth, and we've got 10 kilo ohms, and this gives us this current. Now the second rule we need to know is that the op-amp has got infinite resistance in its inputs, so no current is going to flow into the inputs, it's all going to go through RF. So how much current is going to flow through RF? Well, what we've got to do is just add the 2 currents that we've calculated here, and this is the current flowing through RF. So how do we work out what V out's going to be? Well, we know we've got 0 volts here, and we're going to lose a voltage across RF, and that's going to be the current times RF, V equals IR. So we've got 0 volts on the left hand side of the resistor, we lose that many volts across it, plug the numbers in, and we end up at the output minus 5.5 volts as we had before. Next example is where we've got an AC and a DC signal going in. Now I'm going to treat this as 2 inverting amplifiers. I'm going to deal with the DC and the AC separately. So here we've got 2 volts DC, we've got 3 volts a sine wave going in. Okay, so here's the formula originally. Let's treat it as 2 inverting amplifiers. We've got V out is minus RF over R in times V in for each of the input voltages. Let's plug the numbers in. We've got 20k feedback resistor both times. We've got 3 volts going to the 40 kilo ohm resistor, and the 2 volts going to the 10 kilo ohm resistor. and what we work out, each bracket separately. So the 3 volts gives us minus 1.5 volts, the 2 volts gives us minus 4. What this means, this comes from a sine wave, so the minus sign says that the sine wave is going to be inverted. And the second bracket, the minus 4, means that the sine wave is going to be varying about minus 4 volts. So let's see what we get on the output. So we've got the 2 volt DC input giving us minus 4 volts on the output. And then we've got the 3 volt AC, 3 volts. When that reaches 3 volts above 0, this reaches 1.5 volts below minus 4 volts. So we can see when this rises up, the output falls down.